Um, Good introduction, Don. Thanks very much, and great to hear that you're moving on and going to have some fun starting in November of a different manner. So it's always a great pleasure to join this event, and I tuned in on Tuesday and caught some of the talks, and they were really great. So that was a pleasure. Um, so I'm going to be talking about groundwater monitoring um, from a national perspective down to a provincial perspective and bringing in a bit of international context. You can see my list of co-authors here. A quick nod to them. I won't read them out. You've already done that faster than I can. So I've got a number of slides, and to try and honor Don's request to staying on time, I may snap through a few of them. Let's see if, okay, there we go. So you may have heard about this report. It came out a few weeks ago, Global Water Bankruptcy. Water resources in general, groundwater particularly coming to the fore more and more in water discussions. And the overexploitation is a growing concern as population grows, GDP increases, pressures on water resources, et cetera. And not to get into the breadth and depth of this report, but on the text on the right of the graph image of the cover just highlights how it addresses monitoring in a range of different ways, from water level, recording and documentation to looking at land subsidence or aquifer compaction and water quality degradation from whatever sources. And the need to implement newer technologies in monitoring observation networks to both cost effectively monitor, but also to provide spatial coverage. So in the interview on the current January the 30th, Matt Galloway asked this rather pertinent question about, the challenge of maintaining water resources, and they've always been there, and why do we have this challenge? And so the graphs on the left just highlight that. The top two related to population growth and GDP growth since 1900, and at the bottom two highlighting how precipitation and temperature have changed in those. And you can see that the increase in population pressures, and this is for Canada, are substantive since 1900, and certainly the change in GDP is enormous since the early part of the 20th century. So we really do need to improve our understanding of the water resources we have. And I would be remiss to not touch on the governance issue of water resources in Canada. Water is considered a natural resource. It falls under the jurisdiction of the province and territories with specific areas of responsibility for the federal government. And the document on the left, Freshwater Management in Canada, Jurisdiction by Cote, is where the snapshot on the right comes from, and just outlines some of that. And much of the responsibility at the federal level for water is accommodated under the Canada Water Act. But that's not the only act that deals with water in the federal government. As you might imagine, fisheries has various other acts. And as it's a natural resource, NRCan, my home department, also is responsible for the mapping of water, both groundwater and surface water. So why do we want to have a national monitoring system? And, people are talking about global monitoring. It would seem that between watersheds and global, there might be a role for provincial, which does exist in Canada, and consequently national monitoring. And there's a number of sort of drivers behind the desire for a national monitoring network, both societal policy, and we'll get into some of these in more detail as we move on, and particularly science and technology. The calibration of other data sets, for example, water storage change with GRACE can benefit enormously from having good water level monitoring. Understanding natural processes, aquifer processes or aquitard processes, flow processes, and the impacts on water, whether that's water level through water takings or water quality through not point and non-point source contaminants. So we're focusing on groundwater here, but really we need to consider that we need the whole water cycle and monitoring of that complete cycle. And the graph on the left is from Hinton in Canada's groundwater resources, just highlighting the water cycle from cloud to ocean. And the table on the right just steps through elements of the water cycle: precipitation, snow, glaciers, soil, moisture. In the red box, the two that we're going to talk about a bit more in this talk: permafrost and water storage, which is an integrated component of quite a number of these elements. And under methods, you can see there's a range of methods that are both physical or remote sensing or reanalysis products. And then the key organizations in Canada that deal with these elements. So to move on, we'll groundwater and surface water then. So we have a national monitoring system under the Freshwater Act. It was initiated in 1900, as you can see in the graph on the left, and it's active up to today. This graph was taken from an earlier publication, so it ends in 2011. Things have not changed dramatically since 2011, though. It's a shared network with provinces and also third parties, commonly industry, but they could also be watershed boards. We've highlighted a couple of elements in this graph. The hydrologic decade, where you can see there's a considerable growth in the number of stations in the network. And the red line that is at 1971 highlights the creation of Environment Canada. It's the second national environmental agency in the world after EPA in the United States. The blue color, starting in 1975, represents when cost sharing between the federal government and the provinces was implemented for the network. And in the bottom blue extract from a table, you can see in red the percentage that is either federal responsibility, cost shared with the provinces, 100% funded by the provinces, or is funded by a third party. And the non-ECC operated column there actually equals about 22%. So currently in 2024, according to the Canada Water Act annual report, NHS, the National Hydrographic Service, has 2,900 stations, and groundwater has the rather overwhelming, unbelievable number of 8, I believe it is. That number can fluctuate between, I say 9 here, between 8 to 10, depending upon exactly how it's measured. So this might suggest that as water represents a large part of the water cycle, groundwater that is, there's a need or a value in enhanced groundwater monitoring. And Canada is unique in the world. We're 10 million square kilometers, so second largest country in the world. 9% of the landmass is covered by water. There's nearly 1 million lakes, minus 100,000, which is 62% of all the world's lakes. So there's no wonder that we've been preoccupied with surface water. But what wasn't really fully appreciated up until probably the 1960s is the relative role of groundwater in sustaining surface water. And so 40 to 60% of river flow is actually groundwater, and that can increase to 90% in low flow periods of summer, particularly summer drought periods or the winter. So stepping back then from this Canadian context, we can look internationally. And IGRAC is an international organization focused on groundwater, and they completed a survey a few years ago on national groundwater monitoring programs. And an online search revealed that there were 108 national surveys or national scale monitoring networks. 81 of those profiles they reached out to, and they sent surveys initially to 62 of those 81 countries, and it expanded up to the full number. And from the surveys they sent out, they heard back from 48 countries that are included in this document and discussed individually. And of the G7 countries, of which Canada is one, all of them have monitoring networks. And Canada was included as having a monitoring network. But the caveat about Canada is it's a national network of networks that's delivered through the Groundwater Information Network, and is simply a portal or a telescope into individual provincial networks. And while we'll come back to that challenge a little later. So as identified at the beginning of the talk, there's this call for enhanced monitoring globally. And what are some of the objectives of G7 country monitoring? They are interested in being able to assess quantitatively water levels, which converts into storage changes and is equivalent to resource availability. Trend analysis, how things change over interannually, decadal, even over centuries. The earliest French, I think, documented monitoring well dates from the early 1800s. Obviously to support management decisions, so policy issues, and so on. So having sort of snapshot very briefly in international context, what's happening in Canada. And this slide, rather rich in cover images dating from 1962 all the way up to the present in the Canada Water Agency. And we'll go through some of these right here. So we've had a national dialogue on monitoring nationally since 1962. The Geological Survey of Canada at that point was responsible for groundwater work, and it initiated a conversation about a national network. And in 66, now groundwater had moved to the Inland and Waters branch of Environment or Energy, Mines and Resources. A full scoping document was produced by Gilliland that laid out all of the elements of a national monitoring network, which never came to fruition. And monitoring water and groundwater moved off to Environment Canada in 1971. There was a review of the Water Act in 85 and water policy. And, the repetitive and cyclic commentary of out of sight, out of mind about groundwater emerges or is raised here, and a lack of monitoring. And Pierce in 85 is actually the synthesis of the policy review, and they recommend increased attention to groundwater resources and monitoring. In the first progress report of the policy, the freshwater policy document of 1987 occurs in 1990 by the federal government. And it's noted that groundwater monitoring is an elected area of data collection, and there's a real need to improve on that activity. But not much happens. We arrive in 2003. We still don't have a national monitoring network. And Alfonso Rivera, the chief hydrogeologist at the GSC, initiated a national workshop with the provinces, and the recommendation of a network of networks, which does evolve and emerge over subsequent years and was delivered by the Groundwater Information Network, with a few missing provinces. And currently not accessible due to a few IT issues in the federal government, but it should be back online by springtime. And then in 2005, what does the Senate say in a document titled Water in the West Under Pressure? Not quite the right title, but close. That there's a need for national groundwater monitoring. So coming down to a provincial level, then the Canadian Council Ministers of Environment, they commissioned a survey by a consultant that was reported on in 2010. They sent out surveys to all of the provinces, And lo and behold, it's a shocking revelation that the same comments come back. There is a need for groundwater level monitoring, groundwater quality monitoring, um, to provide the necessary information to support sustainable water management. So a little bit deeper dive then into what's happening with the provinces. So arguably 9 out of 10 provinces have well-developed monitoring networks. Newfoundland is a bit on the edge there. The Yukon has a network, and Northwest Territory has a few wells, and Nunavut doesn't really have an observation network. And the blue boxes are years where a province has published a report that's related to their groundwater monitoring network. And underneath, you can see some of the categories that these reports fall into. British Columbia actually publishes online an operational manual and standard operating procedure, the only province to actually publicly present that information. Any number of provinces provide well site reporting. New Brunswick is notable for its very consistent annual reporting. And then there's a variety of hits in different years on summary reporting, water status, etc. So what are the objectives of these provincial monitoring networks? And they range a whole spectrum. Some of these classes are certainly overlapping. You know, if you're monitoring water level, it's likely that it may be serving multiple purposes. But one thing you don't want to mix is water monitoring for natural processes where it's influenced by anthropogenic processes such as municipal water takings or water takings by others. And so the objectives on a provincial basis are relatively well defined across the board. This is just an insight into some of the reporting. This is an example of British Columbia's annual summary report and some of the elements that it actually documents. And I haven't been keeping track of time, so I won't, languish here too long. But it's a great initiative and building a real continuity about the British Columbia network. Trends and status reports, New Brunswick and British Columbia both are once again notable for their sort of reporting, whether that's annual summary reports or monthly reports, in some cases integrating both groundwater and surface water, and spanning now not only monthly but interannual periods, so you can actually start to see what metrics are showing over those years. Web enable access, and that's certainly critical today. And the table on the right just breaks that down into 4 categories. Which provinces have a landing page? So they consolidate your entry point to a number of other sites. And that's really quite helpful. And you can see that half of the P&Ts with monitoring provide a landing page. Who has interactive maps? And once again, it's relatively well provided. In the case of New Brunswick, they indicate that they rely on GIN, and Nova Scotia provides an interactive PDF rather than an actual map-based or web-based interactive form. Dashboards, Prince Edward Island really, which is the only province with a really clear dashboard that I interrogated, and it's a screen captured on the lower right. And then digital downloads, you can see nearly everyone allows a digital download, thank God. And you can then do your own analysis and visualization in GIS or statistical packages. So overall, from a sort of collective perspective, accessibility to monitoring data is relatively good. So that brings us back then to the network of networks. We have provincial networks. That's the first part of the network. And the second part of the networks of networks, you could argue, is what's being implemented through the Groundwater Information Network. And immediately what comes to mind is, well, what's the level of harmonization or standardization in this exercise? And you can see on the left-hand side, um, there's a number of boxes under 5 interoperable levels. Um, the first 2 are considered cross-disciplinary, and then they are explained in slightly more detail to the right. And a paper that documents this exercise is provided on the far right. And you can see systems and syntax are relatively general, cross-disciplinary, based on OJGC standards. I won't say easily implemented, but are implemented for all of the provinces within the network of network. Data structure and semantics start to narrow in on specific disciplinary aspects of the subject and require more time and effort to harmonize or um, consider for standardization. But once again, in the network of networks, that's being done. So the last item in the oval, the challenging one, pragmatics. That's what we really are interested in. The first 4 aspects of interoperability are all about data delivery. The 5th one, the pragmatics, is about, well, what are you collecting? How's it collected? And what do you know about what you're collecting? And there we have no standardization, no harmonization. And it's hard to know exactly what is being monitored in many cases, what the nature of the engineering construction of the monitor was, what's the exact nature of the piezometer or the measuring recorder that's being employed. Um, so a lot of very significant aspects to understand in terms of data analysis as you try to synthesize across the country. So we are the only country in the world faced with this challenge of wanting a national network, but finding that we are short of the mark in delivering on that scope. And the United States has just recently, in the last 20 years, uh, gone through this exercise. 2007, it was raised as a shortcoming, and the United States Geological Survey, along with other groups, initiated an effort. They obtained funding, and they now have what they consider a national groundwater level network, a quality network, and a network for climate change assessments of water level. So I've got two slides and a conclusion left. Where does that bring us? And we're in the 21st century, and we're talking about point field-based observational data. And is that really, if we're going to plan to build a national network, the well, it is a starting point, but is that the scope and scale that we should be considering, or should we be considering other aspects to integrate into that network and to provide better spatial extent and to move beyond just monitoring, which is a cast type exercise. We know what's happened and we've got a record of it. What's going to happen in the future? So can we actually integrate this with a forecasting process also? And this paper by Condon et al. For the United States, but looking globally, broke this challenge down into 6 elements. The hydrogeological model, so hydrostratigraphy. What is the geological framework and land cover, soils that are going to constrain water movement in the subsurface? An observational network, which what we've been focused on here. Groundwater flow modeling to better understand what's happening away from the observation network. Um, Obviously a database for all of the information that's being collected, an ability to assimilate data from multiple sources. So Earth observation needs to be a key component of a 21st century monitoring network. GRACE is a great example of the value that can be obtained from that, and especially in Canada, where we have good observation networks in the south. but in the mid-latitude and far north, we have very flimsy information support. And then the cyber infrastructure, the online data delivery. So where do we, in that framework of Condon et al., where do we stand in Canada? And this just represents their 6 categories and how that's being implemented or stands in Canada. And the hydrogeological framework has been, version 1 is being produced by Canada and One Water and is progressively being made available through publication. The observation network is available at a watershed provincial level through the network of networks. And from a Earth observation perspective, GRACE and some other sensors that are just coming online in the last year or so. Groundwater flow modeling, well, there's a lot of modeling being done by provinces and also by Canada One Water at a large regional scale. The database is certainly in place. The National Hydrometric Service has a good data structure for surface water. Provinces have their own data repositories for their monitoring data, and then the Groundwater Information Network. Assimilation and inversion, then the integration of GRACE with observational data and modeling to provide some form of forecasting opportunity, and of course the cyber infrastructure. So in conclusion, then, where are we? We've noted that only one province is in NHS. That's New Brunswick with 8 to 10 wells, and that's about 1% of the number of wells that actually occur for surface water modeling across the country. Provincial and territorial networks, 11 of the 13 jurisdictions have reasonably robust monitoring for groundwater levels. We haven't really talked much about quantity, and I didn't really allude to this, but I was focused on level. Much of the data is web accessible. There is a network of networks. There's a lack of fundamental harmonization, and that harmonization is really what's being measured in the field and what are the parameters around those measurements. So that comes to the no standards for monitoring process. I must say that when you take a scan of this exercise, there appears to be very little evidence of collective coordination other than the network of networks. And it's difficult to ascertain how you would use data points within the provincial monitoring networks for different applications. Which wells may be Goody wells, for example, which wells may be falling under the impact of water takings, and which ones are appropriate for water level change of natural processes, and how may their response actually be related to their position in flow systems and landscape. So thanks very much.